Hi, in this lesson we are going to start with Vulkan. The first thing about Vulkan we'll need is the Vulkan instance. All of our Vulkan code will live into a file called graphics, which I create now. We start with the usual pragma ones, and we add the namespace for our project. Inside I will create an empty graphics class. Now we also need to add in the CPP file for this header, where I will add includes for the precompiled header and the graphics header. Then I add the namespace again. Now let's run to the graphics class. We're going to create a Vulkan instance in this lesson, so I start by creating a new private member. Vulkan has all types prefix with vk for Vulkan, so I write down vk instance and name the variable instance. We will use the constructor to initialize our graphics, so let's add it in as well. To initialize the graphics, we will need access to a created window, so I add a not null window pointer as a parameter. And let's add it as a member as well, since we will need access to it later. We're going to have a destructor for clearing our graphics objects as well. And I'll go to the CPP file where I create the constructor and destructor's bodies. And I will initialize the window member with the window parameter of the constructor. Back at the main file, we will create a new graphics object from our namespace, and we will pass the window to it. Now back at the header, you will see that our Vulkan instance is highlighted in red. We need to include the Vulkan header to use that type, which is what I do now. We will also have the graphics class be final, as we won't be inheriting from it. I also now create two private methods. One I call initialize Vulkan and the other create instance. I go to the CPP file to implement them. Initialize Vulkan will go over all of the objects we will create in the course, needed to initialize the API. Create instance will just be responsible for creating the Vulkan instance, and the initialize Vulkan method will call the create instance. On the other hand, the constructor will call initialize Vulkan. We will now start writing the code for creating the instance. In Vulkan, each object that needs to be created will require an info struct being passed in. The instance requires us to write a few structs actually. We'll start with this optional one called vk application info. And I also call the variable appinfo. It is important to put the curly braces at the end here, since this will initialize the struct members to 0. Now each info struct has a member field called S-type. This is short for struct type. If you also go to the struct declaration, you can see this member here also called pNext. You can sometimes chain multiple structs together, and pNext will be a pointer to the next info struct. Any member starting with P is a pointer member. Here you can also look at the members we need to initialize. I copied them over to our new method to have them as a reference. So we were on the S-type. The S-type always needs to be set, and it is really easy to set. Vulkan has a definition for each struct type, and each definition is consisted of the prefix vk structure type, and then the struct name in all caps. In this case, it is vk structure type application info. I might not mention it everywhere throughout the course. The pNext is usually set to a null pointer or not set at all. All the rest are not universal and we need to define based on each struct. For the application info, we need to set the application name, the application version, which I do by calling vk-make-version, the engine name and the engine version as well. And finally, and most importantly, the Vulkan API version that we want to use. For the application and engine name and version, you can set whatever you want. It will not have any effect over the Vulkan output. Next, we will need a new object of the VK instance create info type. I will name it instance creation info and zero it out. Next, I will set the S type, and I construct it from the prefix VK structure type, and then the name of the struct we are constructing. Next, we need to set pNext to no pointer. We also need to set the application info member to the variable we created above. And as you can see, the member starts with the p prefix, so we need to actually pass the address of the variable. Now, when creating an instance, we also need to specify some Vulkan extensions that we want. For example, we will need to have an extension for presenting our frames to the screen. This is actually not a built-in functionality of Vulkan, so I go to the header file to create a new method called getSuggested_extensions. And it will return a span of strings with the extension names. Now I will copy this method signature and go to the CPP file to create its body. Now we called this method getSuggested_extensions because we are actually going to initialize Vulkan with extensions suggested by the GOFW library for rendering on the window. So we initialize a count variable and a pointer to CZ strings. Then we give the GOFW extension variable to be equal to the result of the GOFW getRequired instance extensions. And we pass the address to the count variable as an argument. Then we construct a new span for the return value. And here I correct the variable style to use underscores. Now back at the create instance method, I will set the new span variable with the extensions. We will get these extensions from the getSuggested_extensions method. And now in the instance creation info, we can specify the extensions that we want. This can be done by setting the size of the array of extensions onto the enabled extension count member and the others to the extensions data onto the pp enabled extensions names. We also want to set the enabled layer count to 0. We will be doing layers a bit later. Now, when we have all the structs needed to construct the instance, we can call vk create instance and pass in the instance creation info's address. A no pointer for the memory allocator. A little side note here, in this course we won't be doing custom allocation, so a lot of these methods will be accepting a no pointer for the allocator. This lets Vulkan allocate memory in the best way it can. Anyway, we continue by passing in the address to the instance member field of the graphics class. This function will return a vk result variable. We need to check this result as it will indicate if the call was a success. If we messed up something, we want our application to exit. This is how we're going to mostly handle errors in this course. When creating a custom application, you can choose how to handle errors yourself. I will now try and build the project, but I get a few errors. First, here in the header file, we need to add an include to our window header file. We also need to include GOFW in the CPP file since we used it to get the required Vulkan extensions. And finally, I have missed a semicolon here after the return statement. Now we can build a project and we will get this white screen again. Keep in mind that we are a long way from rendering something, and this white screen will be our greeting every time we run the project. I will still run the project periodically so that I validate that there are no warnings or errors in the console window. As you can see, we get an exit code of 0, which means success for the application. And before finishing this lesson, each time we call vk create something, we need to call a corresponding vk destroy function. We will do this in the destructor. Here I call vk_destroy instance and pass in the instance and a null pointer for the allocator. For safety, we can even check if the instance is not null. This is because the instance, as well as other constructible types of Vulkan, are actually pointers behind. We can also assign it to a null pointer by default. If we follow through the vk instance type, you will see that it's defined with the handle macro. And if we further check the handle macro type, you will see that this is just a type def for a pointer type. This is it for this lesson. In this lesson we created our first Vulkan object, and we learned a lot about how Vulkan objects are created and destroyed. We also requested our basic Vulkan stations that GFW suggested, and we created our graphics class. We will continue in the next lesson.